Hey friends, this is Module 6, Lesson 1. Our learning goal today is I can use metric measurement to model the decomposition of one whole into tenths. So you might notice in that learning goal that sounds kind of similar to all the work that we've done in Module 5 with fractions. When you hear something about wholes and tenths, it sounds like fractions. But today we're going to introduce you to something brand new called the metric system. We're going to be looking at decimal points. All right, let's get started. It says the tape diagram below represents 10 equal bags of rice. Together, they weigh 1 kilogram. So each of those boxes is a bag of rice. There are 10 altogether, and all together, all 10 of them makes 1 kilogram. So I could go ahead and label every single one of these bags of rice until I get all 10 of them counted. So I know that the first bag is 1/10 of a kilogram. 1/10 because it's one out of the 10 total that are in this whole unit of 1 kilogram. If I have 2 bags, it's 2/10. 3 bags is 3/10. 4 bags is 4/10. 5 bags is 5/10. 6 bags, 6/10. 7 bags, 7/10. 8 bags, 8/10. 9 bags, 9/10. And 10 bags is 10/10, which we know 10/10 is one whole. And in this case, one whole is 1 kilogram. So if I were to ask what fraction of the whole is each bag, well, each bag is 1/10 like this, but we labeled each bag as we were counting to. So we kept counting up and adding a tenth each time, but each of them is worth 1/10. So we would just write that it's worth 1/10 of a kilogram because the whole unit is 1 kilogram and one of them is just a part of that. It's just 1/10. How about this? Let's take this to the next step. The directions say that the number line below represents 10 bags of rice. Okay, that sounds like what we just did. Label all of the fractions above the number line. Digit scales read the bag of rice as decimals. Label all the decimals below the number line. Friends, have you ever weighed anything like yourself on a scale and it has a number that comes up with a dot in the middle of it? That dot or period is called a decimal point. And decimal points measure fractions just like we've been measuring fractions in Module 5, but you're not going to see the line between the numerator and the denominator. You're going to see a decimal point in between the wholes and the fraction part. So let's see what I mean. So we've already labeled our tenths on the previous slide. So let's go ahead and on the top of the number line, we're going to label all of our tenths. So we have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. And then the 10/10, for some reason, the line got left out of the middle of the numerator and denominator, but we still know that it belongs there. And 10/10 is the same as one whole. All right, are you ready for the fun part? On the bottom, we are going to label the same units, but in decimal form. So let's go ahead and take a look at 0/10 would just be 0 because 0 is nothing. It's just 0. But you'll notice that it has a decimal point in the middle because if we had one whole unit, it would go in this spot. And if we had part of a unit, it would go here. Well, we do have part of a whole unit right here. This is 1/10. Let me show you what it looks like as a decimal. That is 1/10. We call this 1/10 because this one is in the tenths place. This decimal represents the break between a whole number and the leftover part of a whole. So this is just 1/10. Let's look at 2/10. Oh, that makes sense, doesn't it? Same thing as 1/10, but we just changed it to 2/10. How about 3/10? There it is. 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. And look at what 10/10 looks like. Oh, it doesn't have a 1 over here because that would be a tenth. It has a 1 in the front because remember I said that is representing a whole number. So this is one whole. And that makes sense because 10/10 is one whole. So one whole with no tenths left over. Awesome. So friends, what decimal represents one bag of rice? Let's go back. Remember, these are 10 bags of rice. So let's go back to 1. Oh, yes. And we're looking for what decimal represents one bag. It is 1/10 of a kilogram. That is one bag of rice as a decimal. Okay, let's look at this number line. Okay, friends, so it's your turn. You're going to label the decimals on this number line just like we did in the previous slide. So if you need to go back and look at what I did, you are welcome to do that. If you remember how to do your tenths, awesome. Follow the pattern all the way across. You're going to press pause while you do that and play so we can keep going to answer the questions. All right. Do you have your decimals like this? Awesome. You should have all the way from 0 tenths to 10 tenths, which looks like one whole unit. And let's go ahead and answer these questions. What fraction represents 2 bags of rice? Are you ready? Now be careful, friends. I know you're going to want to just put the decimal, but friends, this is asking for what fraction. So be very careful because we want to see if you're paying attention. We always are going to remember our fractions, and decimals are new for us, but this time we're going to go back to the fraction. So if we call this 2 tenths, do you remember what that fraction looks like? 2 tenths? Like that. 2 tenths of a kilogram. All right, so when it asks for fractions, make sure you give it in a fraction form, not decimal. Now, the next question says, what decimal represents 2 bags of rice? Okay, now we get to go back to our decimal points. So, friends, look at 2 bags. There's 1 bag and 2 bags. There it is. What is that decimal? We still say 2 tenths, but it looks like this in decimal form. And then the last question is, what is 10 tenths equal to? 10 tenths is equal to what? 1 and 0 tenths. Yeah, it looks like this. 1 and 0 tenths left over. All right, let's try these questions. All right, what fraction represents 8 bags of rice? Friends, you're going to be writing a fraction here. Then you're going to answer what decimal represents 8 bags of rice. And then you're going to see if you can write this number, and I'm not going to say it. You're going to write this in word form. If I say it, it'll give away what to write. So you're going to read what it says and write what you think the answer is. Okay, friends, you are going to use your number line. Press pause, answer all 3 questions, and press play to check with me. All right. So question 1, what fraction represents 8 bags of rice? Okay, don't forget, don't get tricked. It's asking for the fraction, which are not shown on this number line. However, if you read this decimal, and this is 8 bags right here, count them up, there's 8 of them. If you read that decimal, it sounds like a fraction. It's 8 tenths. Remember what 8 tenths looks like? Like this, 8 tenths of a kilogram. What decimal represents 8 bags of rice? Oh, well, that is right there. And it looks like this, 8 tenths of a kilogram. And then, friends, you were supposed to write this number. How do we say this in word form? This is 8 tenths. If you say it, you're going to be able to write it in word form, 8 tenths. All right, here are some new types of questions. Look at the directions at the top. Label the number line below with decimals. And we already did that part. And now we're going to show 2 tenths of a kilogram plus 8 tenths of a kilogram, and that equals 1 whole kilogram. And then we're going to name some other pairs of decimals that also add to 1. All right, so let's show 2 tenths of a kilogram right there, and we're going to show how we can add 8 tenths onto it to get to 1 whole. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. These are tenths. If I jump to here, I get a jump of 8 tenths, and that gets me to 1 whole. So 1 kilogram. So what other pairs of decimals could add to 1 kilogram? I'll give you another example. If I start at 1 tenth and I add 9 more tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, that gets me also to 1. So I could say that 1 tenth plus 9 tenths also equals 1 kilogram. Friends, can you think of 2 other pairs that you could add that we haven't done yet? So far we've done 2 tenths and 8 tenths, and now 1 tenth and 9 tenths. I want you to come up with 2 other ways to make 1 whole kilogram, and you're going to write them in your own, on your paper or your whiteboard, whatever you have handy in front of you, and then you're going to press play and check with me. Okay, friends, there's more than 2 answers to this one. There's actually multiple ways that you could make 1 kilogram, but I'm just going to keep going in order since we've already done 1 tenth plus 9 tenths. That made 1 kilogram, and 2 tenths plus 8 tenths. I'm just going to keep going. How about 3 tenths and 7 tenths? If you start at 3 tenths and count 7 more tenths, that gets you to 1 kilogram. And then I just kept going. The next one would be 4 tenths and what? 1, 2, 3, 4, 5, 6 tenths. So 4 tenths and 6 tenths also makes 1 kilogram. If you also did 5 tenths and 5 tenths, that could also work. But those are the only pairs that we are going to write, because once you get to 6, it starts all over again, and you would end up doing 6 tenths and 4 tenths again, just in a different order. So those are the partner pairs that we could use to make 1 kilogram. All right, let's switch now from a number line over to a tape diagram. We can continue to write decimals and fractions with tape diagrams. This tape diagram represents 1 meter. All right, so I want you to visualize that this whole thing from 0 all the way to here to 1 whole is 1 meter, and it's divided into 10 equal parts. All right, we've seen fraction bars like this and also called tape diagrams. So what fraction of the tape diagram is shaded? Well, I see 4 green out of 10 pieces total. So that would be 4/10 of the meter. What's that decimal called? Well, it's called the exact same thing, but it looks like this. It's called 4/10, and it looks like that with the decimal in front of the 4 and a 0 holding that there are no holes filled in yet. We do not have a whole unit shaded or a whole meter shaded yet. All right. So friends, what does 4/10 of a meter plus 6/10 of a meter equal? Do you know? Do you remember? We just did a partner pair like this. It equals 1 whole meter. Yeah, these 4 shaded ones plus these 6 not shaded ones would make 1 whole meter. All right, now the directions are going to change just a little bit. It says the tape diagram below represents 1 centimeter now. Okay, it's divided into 10 equal parts. So instead of calling this whole tape diagram a meter, we're going to call it a centimeter. And I helped you with your label right here so you don't forget. But friends, this is for you. I want you to see if you can come up with what fraction of the tape diagram is shaded. I want you to press pause, try to just come up with the fraction, and if you can challenge yourself to do the decimal, please go ahead and do that, and then press play to check with me. All right, since there's 1 unit shaded and there's 10 parts altogether, we call that 1/10. That is the fraction of the shaded tape diagram. As a decimal, we would write 1/10 also, and it would look like that with the decimal in front of the 1. That is 1/10 of a centimeter. And friends, how many 1/10 equal 1 centimeter? How many 1/10 equal 1 centimeter? How many of those tenths units would you have to have? 10 of them. That is what it would take because there are 10 of these 1/10. This is a tenth, and this is a tenth, and this is a tenth. And if you count them all, there's 10. Okay. Now, this one really is for you from beginning to end. You're going to read each question on the bottom, and you are going to see if you can just quickly write the answers on whatever you have in front of you, whether that's a computer or whether that's a piece of paper or a whiteboard. You are going to write down what you see. So what fraction is shaded, what decimal is shaded, and then you're going to read that last question and see if you can figure it out by yourself. All right, press pause and then play to check with me. Okay, what fraction of the tape diagram is shaded? I see that it's 9/10 of a centimeter. Yes, very good. What decimal of the tape diagram is shaded? Well, it's still 9/10, but 9/10 looks like this as a decimal. 9/10 of a centimeter. And how many more tenths do we need to make 1 centimeter? Friends, if we had 1 more shaded, we would have a whole centimeter. So we would just need 1 more tenth, 1/10. All right, you guys, our learning goal today was I can use metric measurement to model the decomposition of 1 whole into tenths. And now you know metric measurement means using decimals. See you guys in lesson 2.